We spend so much time thinking about how to make AI learn more, learn faster, get smarter. But what if one of the real keys to building safe and trustworthy AI isn't about learning at all, but about forgetting? Today, we are diving headfirst into the absolutely fascinating world of machine unlearning. I mean, just think about it for a second. What if an AI accidentally memorizes your private medical records, or your company's biggest trade secret, or maybe just a ton of copyrighted material? How do you get it to unlearn that specific piece of information? This isn't some sci-fi scenario. It's a huge challenge facing AI right now, and it's the exact problem machine unlearning is designed to solve. And this need to forget is literally everywhere. We're talking about really important stuff, like removing personal info to comply with privacy laws like GDPR and its whole right to be forgotten. Or think about a medical AI. You've got to purge outdated or wrong data so it doesn't make a bad diagnosis. And of course, you have to make sure your model isn't spitting out copyrighted material it learned from the internet. The stakes here are just incredibly high. So, okay, if forgetting is so critical, why is it so ridiculously hard for an AI to do? Well, that's what we're going to get into in our first section here, the AI's amnesia problem. Right now, the old school solution is, well, it's brutal. If you want to get rid of just one piece of bad data, you have to literally throw the entire AI model in the trash and retrain a brand new one from the ground up, just without that single data point. It's like demolishing an entire skyscraper just because you need to repaint one apartment. It makes no sense. And when you put the two side by side, the difference is just night and day. Retraining is painfully slow. It costs a fortune in compute power, and for the gigantic models we have today, it's basically impossible. Machine unlearning, on the other hand, is the opposite. It's fast, it's efficient, it's precise. It's not demolition, it's a surgical operation. So if retraining is the sledgehammer, what's the scalpel? Let's get into section 2 and properly meet the hero of our story, machine unlearning. So what is it really? Well, machine unlearning is basically a technique that lets you go into an already trained model and surgically remove the influence of some specific data you want gone. The whole point is to end up with a model that acts exactly as if it had never seen that data in the first place, all without that massive cost and time of a complete do-over. And the way it works is pretty straightforward. First, you have your normal training phase, or the model learns from a big data set. But then comes the really critical part, the unlearning phase. A user sends a request to remove something, and the server runs the special unlearning algorithm. And finally, you get to the post-unlearning phase, where the new, updated model is back online and ready to go. Simple as that. But of course, here comes the twist. A powerful new tool like this also creates powerful new ways for things to go wrong. So for section 3, we need to talk about how unlearning itself can be attacked. And hey, don't just take my word for it. Researchers like Liu and his team are pointing out that these unlearning systems have real vulnerabilities that can lead to some serious security and privacy issues. So the very tool that's designed to protect our privacy can actually be turned on its head to violate it. Okay, so the first major threat is something called information leakage. Basically, attackers can spy on the unlearning process itself. By carefully analyzing the tiny differences between the model before and after the data was removed, that's what we call model discrepancy, they can figure out what that forgotten data was. It's kind of like looking at the smudge marks on a piece of paper to figure out what word was just erased. But it gets even worse. The second major line of attack is called malicious unlearning. And this is where an adversary doesn't just spy on the process, they actively try to corrupt it from the inside. And there are two main flavors of this. You've got direct attacks, which are pretty simple. The attacker just makes a malicious unlearning request to try and break the model right then and there. But then you have preconditioned attacks, and these are so much more sneaky. They're like planting a digital time bomb during the training phase that just sits there, dormant, waiting for a very specific unlearning request to set it off. So check out how this works, because it is deviously clever. First, the attacker poisons the training data, but they also add some harmless mitigation data that basically hides the poison's effect. So the model gets trained and it looks perfectly fine. Then, much later, the attacker makes a simple request to unlearn that harmless mitigation data. The system does its job, removes it, and in doing so accidentally removes the very thing that was holding back the poison. The backdoor is now active. It's a brilliant and frankly terrifying strategy. Okay, so that all sounds pretty scary. But for every clever attack, there's usually a clever defense being built. So let's pivot to section 4 and talk about the unlearning defense. So yeah, how exactly do we fight back against these kinds of attacks? The good news is, researchers aren't just finding problems, they are actively building all sorts of countermeasures to protect these systems. And the best defense is a multi-layered one. You can have defenses before unlearning even starts, trying to spot and block malicious requests. You can have defenses during the process, monitoring for any weird behavior and hitting the emergency brake if needed. And then after the process is done, you can add protections to the final model to shield it from that information leakage we talked about. But this is where the story gets really, really cool. The defense isn't just about building up walls. It's about turning the attacker's weapon back on them. It turns out that unlearning itself can be the cure. Think about it. If your model has been infected with a backdoor, what's the best way to fix it? You can use machine unlearning to go in and surgically remove that exact piece of poison data, effectively healing the model. And you can use it proactively, too, to unlearn harmful biases, copyrighted text, or other junk to make the AI safer and more aligned with our values. So unlearning isn't just a delete button, it's a fundamental tool for making AI better. So we have this amazing new tool, and we're building defenses against its misuse. That brings us to our final question. What's next for forgetful AI? Because, trust me, this field is moving at lightning speed, and the next set of challenges are even bigger. The next frontiers are pretty mind-bending. Think about federated learning, where a model is trained across millions of different phones. How do you make that system forget something? Or what about graph data, where everything is about connections between things? How do you unlearn a single relationship? And the big one, for huge models like ChatGPT, how do you remove not just a fact, but an abstract idea or a harmful behavior? These are the massive questions researchers are tackling right now. Which really leaves us with one final big idea to chew on. As AI gets more and more powerful and woven deeper into the fabric of our lives, is it possible that teaching it how to forget will become just as important or maybe even more important than teaching it how to learn? It's a huge shift in how we think about building AI that's not just smart, but also safe and responsible.